Hello children, today we shall welcome George Simon. Yes, today our topic is Ohm's law. We shall have our discussion of Ohm's law with a suitable circuit diagram. The materials required for the circuit are a resistance wire, nickel wire, ammeter, voltmeter and 4 cells, each of 1.5 V. Okay, the connections are as shown in the figure. Now, when one cell is connected, after connecting one cell, we have to note down the reading in ammeter. You know, ammeter is a device used to measure electric current. So note down the reading here. Say that is when we use one cell, number of cells, the ammeter reading, say let it be 0.1 ampere. When it is 1 ampere and at the same time measure the potential difference across this with the help of voltmeter, that is 0.4 V. Next, let us connect two cells and note down the reading. When we connect two cells, the reading in ammeter, say it is 0.2 and here it will be 0.8. Let us repeat with 3 and 4 cells. In case of 3 cells, say now the reading in the ammeter is 0.3 ampere. In voltmeter it is 1.2. When 4 cells, 0.4, 1.6. Let us plot the graph of VI. This is the current I and measured in ampere, potential difference V and unit V. Okay, so this is y-axis and x-axis. 0.1 ampere current. For 0.1, the current, okay, let us mark readings like this: 0.1, 0.2, 0.3, 0.4, 0.4, 0.8, 1.2, 1.6, 2.0. If when the current is 0.1, what about the reading of potential difference is 0.4? Hence the coordinates give this point. Next, 0.2, 0.8, 0.2, 0.8 we get here. The point whose the coordinates, you know basically how to mark the points: 0.3, 1.2, 0.4, 1.6. Then join these points. By joining these points, we get a straight line. This verifies Ohm's law. This is what we say Ohm's law. Then what is Ohm's law? See here, we find this relation between I and V. What is that relation? As the current increases, what about the potential difference also increases? Or as the potential difference increases, the current also increases. Thus, mathematically, we can relate like this: the potential difference across a conductor in an electric circuit is directly proportional to the current flowing through it. Therefore, mathematically we get this: V is proportional to I. When we get the ratios here, V by I, what we will get? Let us check this. 0.4 by 0.1 gives 4. 0.8 by 0.2 equal to 4. 1.2 by 0.3, 12 by 3, 4. Next, 1.6 by 0.4 gives 4. Hence, each type here we get some V by I, V by I, V by I. But here it is found that a constant. Therefore, what is that constant stand? Okay, what does this constant stand for? Means here this constant stands for the resistance of the conductor. Therefore, this straight line verifies Ohm's law. What does that mean here? V is proportional to I. When we convert this proportionality sign into equal, we know we have to introduce a constant. What is that? Means the ratio V by I equal to R. V by equal to R. Therefore, here it comes VIR. VIR. This is what we said the mathematical form of Ohm's law. What is this R? We know now. That is what the resistance of the conductor. Hence, Ohm's law holds good when the temperature remains constant. Hence, children, now we shall put the law like this. The potential difference of a conductor is directly proportional to the current flowing through it, provided the temperature remains constant. Hence, V is proportional to I. Therefore, V equal to IR. Here, R stands for resistance. What is the resistance? Resistance is the property of a conductor by which it opposes the flow of electric charge, nothing but electric current. The property by which the conductor opposes or resists the flow of electric charge. That we say what? Resistance. Okay. Then, what is the SI unit of resistance? Resistance is measured in SI unit by using what? The Greek symbol Ohm. Greek symbol, this is omega, the 24th Greek alphabet. This is the symbol for the resistance of what? The conductor. What is then SI unit of resistance of the conductor? It is Ohm. Ohm, and it is denoted by what? Omega, the Greek letter. Okay. Now we shall try to define 1 ohm. For that, let us take the mathematical form of Ohm's law. Hence, here R, the resistance, equal to V by I. Then the SI unit of resistance is ohm. Hence, this implies 1 ohm equal to V, potential difference. If it is 1 volt, then I, the SI unit of electric current is ampere. If 1 ampere, therefore, in the presence of 1 volt potential difference, if 1 ampere current flows, then the resistance exerted by the conductor is said to be 1 ohm. Okay, children. Now let me brief you about so far what we have discussed in the questions and answers format, which would help you to prepare for your examinations, children. Once again, I welcome you all to understand Ohm's law. First, let us know about the great person George Simon Ohm. George Simon Ohm was a German physicist, best known for his Ohm's law. The physical unit of electrical resistance
The Ohm was named after him. Ohm, who was born on Erlangen in Germany, seems to have acquired his interest in science from his father, a skilled mechanic. He studied at the University of Erlangen and then taught at Cologne Polytechnic in 1817. Name the law which gives a relationship between current I flowing in a metallic wire and potential difference V across its terminals. Who proposed this law? Ohm's law gives the relationship between current I flowing in a metallic wire and potential difference V across its terminals. This law was given by a German physicist, George Simon Ohm, in the year 1827. Now, children, let us try to define Ohm's law. State Ohm's law. Ohm's law states that the potential difference V across the ends of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. If V is the potential difference applied across the ends of a conductor through which current I flows, then according to Ohm's law, V is proportional to I, that implies V equal to IR, that implies I equal to V by R, where R is the constant proportionality called resistance of the conductor at a given temperature, the most important condition at a given nothing but constant temperature. Here I have given you two questions, children. State true or false. First one, the electric current flowing through a conductor is directly proportional to its resistance. If the resistance of a conductor is doubled, then current gets halved. These two questions you try to answer after the lesson. Now, related to Ohm's law, we have one more important factor is its circuit diagram. Hence, children, draw a circuit diagram used for studying Ohm's law. This is the one. So, this circuit diagram has a resistor of resistance R and voltmeter connected in parallel. Then the cells are connected, ammeter and plug key, and then the current flows from plus to minus, positive terminal to negative terminal. Next, what is VI graph of ohmic conductor? What is that ohmic conductor? A conductor which follows Ohm's law, which satisfies, which holds good Ohm's law, that we say ohmic conductor. Draw the same. That means we have to draw now the VI graph. Already we discussed, children, with that numerical activity. The graph between the potential difference V and the corresponding current I is found to be a straight line. The graph between V and I, the current, is a straight line passing through the origin for ohmic metal conductors is called VI graph. Just here you see along x-axis, here current is taken, along y-axis potential difference is taken. As the current increases, what about the potential difference? Increases. As the potential difference increases, current increases. The resultant graph is what? A straight line. This indicates Ohm's law. V is proportional to I. V equal to IR. The factor R is known as resistance, that we know. Therefore, here that factor R, resistance, is constant if the temperature of the conductor remains constant. Then what is meant by resistance of a conductor? The property of a conductor the property of a conductor by virtue of which opposes or resists the flow of charges through it is called resistance. Resistance of a conductor is given by R equal to V by I. Then what is the SI unit of resistance? The SI unit of resistance is ohm and is represented by the Greek letter omega. Let us now try to define 1 ohm. We know the formula for R. It is R equal to V by I. SI unit of R is ohm and the potential difference is volt. Current is I, that means it is measured in ampere. Hence, to be 1 ohm, what should be V, what should be I? Just here you see, define 1 ohm. Resistance is said to be 1 ohm if a potential difference of 1 volt, resistance is said to be 1 ohm if potential difference of 1 volt across the ends of the conductor makes a current of 1 ampere to flow through it. Hence, children, 1 ohm equal to 1 volt by 1 ampere. By using symbols, we could write like this: 1 ohm equal to 1 volt by 1 ampere. Now, related to resistance, that means with the knowledge of resistance, by using the knowledge of resistance or the meaning of the resistance, now we shall try to define some important terms related to conductor. Variable resistance. What is this? A component used to regulate current without changing the voltage source is called variable resistance. Hence, that means resistance can be varied without using what? The change in sources of voltage, that we say variable resistance. Rheostat, a device used to change the resistance in an electric circuit is called a rheostat. Rheostat is a device used to change the resistance in an electric circuit. Good conductor, a component of a given size that offers low resistance. If the resistance is very low, then we say it is a good conductor. Hence, once again, a component of a given size that offers low resistance to the flow of electric current is a good conductor. Example, silver, copper, aluminium, etc. Resistor, a conductor having some appreciable resistance. What does this mean? That appreciable is nothing but having some definite. For example, 1 ohm, 5 ohm, 10 ohm, 15 ohm, like that. Resistance is called a resistor. Once again, resistor, a conductor having some appreciable resistance is called a resistor. Example, which we use as resistors, alloys like nichrome, manganese, constantan, and so on. Then, how to define poor conductor? A component that offers higher resistance. What is the meaning of resistance? Nothing but the virtue, the property of a conductor that opposes the flow of electric charges. If it is very high, then we say it is a poor conductor. Here you see a component that offers higher resistance than conductors to the flow of electric charge is called a poor conductor. Mercury, of course, a metal; lead, a metal; stainless steel, an alloy. All these are the best examples for poor conductor. Means they offer high resistance, means they oppose maximum for the flow of electric current. Then insulator, a component which offers very high resistance to the flow of electric current in an electric circuit is known as insulator. Example, rubber, drywood, plastic, etc. I hope now you have got clear idea about Ohm's law, its equations, that means mathematical form, its SI unit, and so on. Now children, we shall try to solve some
Numericals. First one, how much current will an electric bulb draw from a 220 source? Hence, here given potential difference. 220, we know it is V. 220 SI unit is volt V. If the resistance, first let us write in volt and the symbol, then the magnitude and its SI unit, ohm. What we have find out? Current, I. We know the relation between V, R and I by Ohm's law. V equal to I R. Which is unknown factor here? The unknown factor is I. Therefore, the unknown factor is I. Hence, I equal to V by R. Let us substitute. V is 220. V is 220 divided by 1200. Now come to the rough work. 220 by 1200, then 60. Let us divide 0.1. 60 is 50, then 8 times it goes, 4, 6, 8 are 48. Then again 200, 3 times, like that it goes. Therefore, approximately I equal to 0.183 ampere. Now, in the second one, what would be the resistance of the conductor? Given. If the current flowing through it, current I 0.35 ampere, when the potential difference, what is the symbol? V, is 1.4 volt. What would be the resistance? R. The relation among I, V, R, we know by Ohm's law. V equal to IR. Therefore, R equal to V by I. Now let us substitute. V 1.4, 0.35, come to the rough work, 14, then understood children? 1.4, after the decimal 1 digit, after the decimal 2 digits, therefore we get like that. Then 35 ones are 35, 4s are, hence it comes 4 ohm. Write that ohm, you take some time and write neatly. Assignment on Ohm's law, sub number 1. When a 12V battery is connected across an unknown resistor, there is a current of 0.25 mA. Here children, mA means milliampere. That prefix milli stands for 10 power minus 3. Convert this into SI unit as 0.25 into 10 power minus 3 ampere. Converting that into that 10 power minus 3, then you do it. Find the value of the resistance of the circuit. How much current will an electric bulb of resistance 1100 ohm draw from a 220 source.